Today we're going to be talking about this reaction that is measuring specific heat. We're calculating the heat a reaction absorbs or releases. So we can calculate using math how much heat a reaction gives off or requires. Now, these are all called specific heat problems. All specific heat is the amount of heat required to raise the temperature of 1 gram of that substance by 1 degree Celsius. We're going to talk about that more later. What I want us to work on today is this idea of Q equals MC delta T. Now, we're going to be able to solve these problems by the end of the class today using this formula. So here we have Q equals MC delta T, where Q is equal to the heat absorbed or released. Normally, it's in joules. We'll look at calories later, but most of the time today we're going to see joules. M is mass of the sample, and that's in grams. C is specific heat of the substance. It can either be in joules over grams times Celsius or calories over grams times Celsius. It's dependent on your Q here. So if you have Q in joules, you're gonna have to have your specific heat in joules. If you have your Q in calories, you're gonna need to use the one with calories. Pretty obvious. The last thing we have is delta T. This is the change in temperature. Delta is change. So that's just a change in temperature. What's interesting about this is it's measured in Celsius, not Kelvin. So forget Kelvin from gas laws. We're back in Celsius. Only use Celsius. No need to convert. Don't even think about that. So we keep it in Celsius. Delta T, to find delta T, it's the T final minus T initial, okay? So you have to do final first minus the initial. This is on your formula chart. The thing that sometimes can be tricky is they'll just say the temperature was raised or lowered 15 degrees. If they don't give you a final or initial, most of the time that is your delta T. Okay, so this is our formula. This is it broken down. You will have this on the side to reference to as we go through these problems. The first thing you're going to need to do is read the problem, okay? Keeping in mind what our variables mean. 5 grams of copper was heated from 20 degrees Celsius to 80 degrees Celsius. How much energy was used to heat Cu? So when we're looking at how much energy, that's going to be our Q. We don't know how much energy we used. So I'm gonna put a question mark right there. You can put an X, you can put a question mark, whatever you want. Let's go back to the problem and circle what we're given. 5 grams, that's our mass. 20 degrees Celsius to 80 degrees Celsius. So obviously this is gonna be our final because we're going from something to something else. This is our initial. Okay, we can put that down here. It's going to be 80 minus 20 equals to 60 degrees Celsius. How much energy was used to heat Cu? We already put that in there. And heat capacity of Cu is 0.092 joules per grams of Celsius. Okay, sweet. So I have everything very similar to the gas law problems. We can just plug everything in and then solve for what we need to solve for. So remember, our equation is Q equals MC delta T. We don't know what Q is, so we'll just leave that right there. M is 5. C, 0.092. Delta T, I'm using this number. It's 60, okay? So all you have to do is multiply those 3 numbers together. When you do that, you should have 5 times 0.092 times 60 equals 27.6. Then looking back over here, that's going to be in joules. So 27.6 joules. Okay, that is how you solve number 1. You can do number 2 in the exact same way as number 1. I'm going to let you go ahead and do that problem.